Our lesson today, algebraic expression. The objectives of this lesson: know the meaning of degree of a polynomial of one variable, write a polynomial of one variable in order, calculate the values of a polynomial for particular values of its variable, add, subtract, and multiply polynomials of one variable. What is the monomial? Monomial is of the form composed of coefficient and literal part. In this example, coefficient is 5 and the literal part is x power 3. X is variable. Power 3 is degree of the monomial. So, monomial composed of coefficient, literal part. Coefficient times multiply by literal part. Examples: 4x2 is monomial composed of coefficient, literal part, minus 2y power 5, monomial x, monomial x, monomial x equal 1 times x power 1. So, coefficient of monomial x is 1 coefficient and degree also 1. So, x is monomial, minus 1 over 5, x2 is monomial, 2 is monomial, 2 is constant monomial of degree 0, because since 2 is equal 2 times x power 0. So 2 is constant monomial, degree 0, because x power 0, 1. So x power 0. And the power is degree, so degree 0. Similar monomials have the same literal part. So similar monomials have the same literal part. For example, 3x2 and minus 2x2. The literal part of the first is x2 and the second also x2. So are similar monomials. So 3x2 and minus 2x2 are similar monomials because same literal part. x2, x2. The difference only of the coefficient. Coefficient 3 different minus 2. The difference only the coefficient, and literal part same literal part, so similar monomial. Product of monomials, any two monomials can be can be multiplied together. How? Example: 5x2y times multiplied by 4x5 y power 2 equal times. So monomial times monomial. So we multiply the coefficient. So we multiply the coefficient. Coefficient of the monomial is 5. The coefficient of the monomial is 4. So multiply the coefficient. 5 times 4. 5 times 4 equal 20. So, and multiply the same base together. So same base x, x2, x5. Multiply x2 by x5 because same base. So x2 times x5 equal x power 2 plus 5, 7. So 2 x power 7. And multiply the other variable. So the other variable y times y2, y power 2. So y times y power 2 equal y power 1 plus 2, 1 plus 2, 3. So y power 3. To get 20x7 times y power 3. Addition of monomials. Addition of monomials. Only similar monomials could be added or subtracted. So only similar monomials could be added or subtracted. Example, 3x2 plus minus 5x2. The monomial 3x2 and minus 5x2 is similar monomial. So can be add or subtract because similar monomial x2, x2. Because only similar monomial could be added or subtracted. So 3x2 and minus 5x2 similar monomial. So 3x2 plus minus 5x2 only the coefficient added or subtracted. So 3 minus 5, 3 minus 5 equal minus 2. And the literal part x2, x2 equal x2. The same literal part x2, x2, x2. And the coefficient added or subtracted. 3 minus 5 equal minus 2. So to get minus 2 x2. Opposite monomials. Opposite monomials are similar monomials. Similar monomials with coefficient opposite. So similar monomials with coefficient opposite. So for example, 3x2y and minus 3x2y is similar monomial. Similar monomial because x2y, x2y. Similar monomial, same literal part. Same literal part. So similar monomial. And the coefficient is opposite. 3 minus 3. So the two monomials is opposite monomials because similar part, similar monomials, and the coefficient is opposite. So 3x2y and minus 3x2y is opposite monomials. Remark, the sum of two opposite monomials is 0. So the sum of two opposite monomials equals 0. 3x2y plus minus 3x2y equal 0. Remark, 31 over x2 is not a monomial. So 31 over x2 is not monomial because according to the definition of the monomial, should be multiply between the coefficient and literal part. Multiply between coefficient and literal part. The coefficient and literal part is divide, so not monomial. Algebraic expression is a sequence of monomials add or subtracted. So example, px equal 5x6 minus 2x2 plus 3x plus 4. That is polynomial. So that is polynomial. Px is the name of polynomial. Px name of polynomial. Each term is monomial. 5x6 is monomial, minus x2 is monomial, 3x monomial, 4 is monomial, so each term is monomial. To take two terms is binomial, so 5x6 minus 2x2 is binomial, so 5x6 monomial, 5x6 minus 2x2 is binomial. Three terms is trinomial. So 5x6 minus 2x2 plus 3x is trinomial. Example, 3x5 minus 5x3 plus 4x2 minus x plus 7 is polynomial. So polynomial. 2x4 minus 7x2 is binomial. So 2x4 minus 7x2 is binomial because two terms, so binomial. Two x2 minus 3x plus 5 is trinomial. X power 3 minus x2 plus 1 over x is not polynomial because 1 over x is not monomial. According to the definition of monomial, should be multiply between coefficient and literal part. 1 over x is divide between the coefficient and literal part, so not polynomial. Particular value of a polynomial given px equal 2x2 minus 6x plus 4. Calculate p0 and p1. So p0 equal 2 times 0 power 2 minus 6 times 0 plus 4. So equal 2 times 0, 0 minus 6 times 0, 0 plus 4. So equal 4. P1 equal 2 times 1 power 2 minus 6 times 1 plus 4. So equal 2 times 1, 2 minus 6 times 1, 6 plus 4. So equal 2 minus 6 equal minus 4 plus 4. So equal 0. So P1 equals 0, P0 equal 4. Operations of the polynomials. Consider the two polynomials in X, Px and Qx. Addition. To add the two polynomials, then we write then one after the other, keeping the signs of all the terms. So Px equal 3x2 minus 1, Qx equal 2x3 minus 2x2 plus 3, keeping the signs of all the terms. We reduce, if possible, the like terms, the similar terms. So calculate the similar terms. 3x2 and minus 2x2 is similar monomials because same literal part, x2, x2. So calculate 3x2 minus 2x2. 3x2 minus 2x2 equal 1x2. So equal x2. Minus 1 plus 3 equal plus 2 plus 2x3. So equal 2x3 plus x2 plus 2. subtraction. To subtract px minus qx, we write then one after the other, changing the signs of all the terms of qx. So px is 3x2 minus 1, and changing the signs of all the terms of qx. So qx plus 2x3 minus 2x3, changing the sign. Minus 2x2 plus 2x2 plus 3 minus 3. So we reduce if possible the like terms, the similar terms. So reduce the similar terms. The similar monomials, 3x2 and 2x2 is similar because same literal part, x2, x2. So calculate 3x2 plus 2x2. 3x2 plus 2x2 equal 5x2 minus 1 minus 3 equal minus 4 minus 2x3. So equal minus 2x3 plus 5x2 minus 4. Multiplication. We multiply successively all the terms in one by each of the terms in the other. Then we reduce, if possible, the like terms. So multiply successively all the terms. So 3x2 minus 1 times 2x3 minus 2x2 plus 3. 3x2 times 2x3 equal 3 times 2 equal 6. x2 times x3 equal x2 plus 3 equal 5. So x5. So 3x2 times 2x3 equals 6x5. 3x2 times minus 2x2, so 3 times minus 2 equal minus 6. x2 times x2 equal x4. So 3x2 times minus 2x2 equal minus 6x4. 3x2 times plus 3 equal 3 times 3, 9. 9x2. So 3x2 times 2x3 equals 6x5. 3x2 times minus 2x2 equal minus 6x4. 3x2 times plus 4, 3x2 times plus 3 equal 9x2. So minus 1 times 2x2 equal minus 2x3. Minus 1 times minus 2x2 equal plus 2x2, because minus times minus plus 2x2. Minus 1 times plus 3 equal minus 3. We reduce, if possible, the similar terms. So 6x5, so 6x5 minus 6x4 9x2 and 2x2 is similar monomials because same literal part, x2, x2. So calculate 9x2 plus 2x2 because similar monomial. So 9 plus 2 equal 11. So plus 11x2 minus 2x3. So equal 6x5 minus 6x4 minus 2x3 plus 11x2.